Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 11, work and energy, right? So as like in the part 1 was the introductory part to the lesson where I already gave you an idea of what exactly work and energy is in short, right? It was not that descriptive that we are doing in like the further part of the lesson. It's just that whatever basic information you should be having before starting the lesson that I have provided you all in part 1. So it's like when you meet someone for the first time, you only come to know few things about them, and as in when you meet them again and again, what happens? They become your best friend, so you know their likes, dislikes, everything, right? Same way we are going to do with the lesson. Okay, now as we are moving forward, you will be the best friend of the lesson, and you will be knowing each and every concept of the lesson, work and energy. Okay, so in part 2 and 3, we have already started with the lesson. We discussed on what exactly work is, scientifically how can we define work, or scientifically what is work, right? Then we even we are just left with one small part, and then we will be starting with energy, if you all remember. So work is almost done. Whatever like concepts were there under work, we have like almost done with that. Now, after discussing that small part, we'll be starting with energy, where we will be discussing on different kinds of energy, different forms of energy, then how to derive the kinetic energy, what is potential energy, how can we derive it. Okay, after that we have conservation of energy to discuss. So like this, we have this concepts which subtopics which have been left to discuss as of yet, right? But if you remember, in short, we have so many activities and examples which have been given. As you know that there are numericals in the lesson as well, right? There are like some sums which have been given. So we'll be going through those activities and exercise, and if possible, everyone, please make sure if you have all the materials which have been required with you, please make sure that you are doing that activity, because you learn a lot when you perform it on your own, when you perform the activity on your own. So I want you all to make sure that you are like collecting the materials that have been required and performing the activity as and when required. Okay, so now before I proceed with this part 4, I want each one of you to please revise each and everything that we have studied so far in the lesson. Like, you might have taken so many notes till now, right? So I want you all to please go through it quickly. I hope you all are revising each and everything. You have to make it easier for you to revise, and you have to make it easier to revise the whole lesson. Like suppose if you have your exam tomorrow, you have so many things to go through, right? But if you have this notes with you, it will become easier for you to revise everything. And self-made notes are very important because you learn many things from them, right? So make sure you go through it properly. So now I'm going to show you the slides, like what we have discussed till now. Okay, so we have started with work, and we started with like not much work in spite of working hard, because there is a different, you can say, meaning of work in science, right? So here we have so many examples where they have tried to make us clear when exactly the work has been done and when it is not done, right? So please go through the slide very thoroughly, everyone. I hope every one of you are revising this slide. After this, we discussed on this activity 11.1. So there are three different questions which have been asked. I want each one of you to answer them. You don't have to revise. You have to revise it like you know it, and you are saying like what is the answer to that to yourself. Okay? After this, we discussed on the scientific conception of work, because in last to last slide you studied of different examples and situations where according to us we say that it's work, right? But it's actually like no work is been done in that case, right? So depending on that, we have some scientific conceptions which are different from the ones that we follow. Like if I'm mentally or physically doing something, I'll say that I'm doing a work. But according to science, if there is no force which is exerted on the object, and if there is no displacement, it means no work has been done. It means zero work is done over there, right? So the situations and everything are been given on this slide. I want you all to be very much thorough with this slide. So please go through each and every statement properly. Okay? So I hope every one of you are going through it. Then after this we discussed on this activity 11.2. So there are like 2 3 question marks that you can see on screen, right? So now your basic motto should be answering them. Like when you go through the slide, make sure you answer them. You try to answer them, okay? After this activity, we even discussed on this activity 11.3. So you might have written the situations already, right? If we can come up with any other situation now, we can add on to that, or whatever we have written, just try to think on it or relate it. Okay? I hope you all are going through it. After this 11.3, we discussed on like work done by a constant force. So how exactly we came up with the formula for work that is equal to force into displacement, right? So that is being like clearly explained over here on this slide. I want each one of you to please go through it quickly. I hope you all are going through this slide thoroughly because this is again very important. Okay, you'll get a direct question to derive this, so make sure you know it already. So here we have more information on work that has been given. So I want you all to please go through it as well quickly. So after this we discussed on this example 11.1. I want you all to please go through this as well. I hope you have understood this example, like how exactly it has been calculated. It's the same thing that we discussed over here under work, right? Just a second. Whatever we have discussed over here, this example that they have given is exactly the same thing. Okay? Then we again discussed on like one different example in detail where we discussed on the force and the displacement part, right? So I just want you all to please go through it as well. So we have discussed earlier, like we need to discuss this activity 11.4, right? So now see, we have this activity 11.4 to discuss. What we have over here is, consider a situation in which an object is moving with a uniform velocity along a particular direction. What is happening? An object is moving with a uniform velocity along a particular direction. Now a retarding force, now because it's force, a retarding force F is applied in the opposite direction. What has happened? A retarding force F has been applied in the opposite direction, right? So that is, angle between two direction will be 180. How much it would be? It would be 180. Okay. So let the object stop after displacement S. So over here the object will stop after displacement S. Okay. Now see, we have an example over here. A porter lifts a luggage of 15 kg from the ground and put it on its head 1.5 meter above the ground. So you need to calculate the work done by him on the luggage. What do you think? Is there any kind of work that has been done on the luggage? So for that, what you exactly need to do is, like, if you have to calculate this, we need to write the given thing first. Okay? What are we going to write? We are going to write the given thing first. So we know that mass of the luggage given is m is equal to 15 kg, right? Then the displacement for that s is equal to 15.5 meter, right? That is the given thing. Now we have m and s. So we know that force work is equal to force into displacement, right? So force, we know that we can write force as m into g, that is mass into gravity, right? So m and g value is always going to be constant, right? So mass given is 15 into displacement is 1.5, and it's like g is taken to be as 10, like it's 9.8 usually, but here they have taken it as 10 meter per second, right? So we have that. So sorry. After that, you'll put the values and you will write the answer. Okay? I hope you all are calculating it, and once you calculate it, you'll get the answer as 225 Newton meter, and we know that we can write this Newton meter as joule as well, right? So they have written the same. I hope you all are going through it. Now we have the next thing to discuss, that is energy. Now we know that if you don't have any energy, what will happen? You won't be able to carry out any work, because if you even have to lift something, you need energy for that. For walking you need energy, right? So everything that we do needs energy. Okay, so that is why the first statement that they have given, that life is possible without energy, and we all agree to it, right? Life is impossible without energy, and the demand for energy is ever increasing. Now we don't have only one kind of energy that we are discussing. Okay, we have different forms of energy. Like we have heat energy, light energy, electrical energy, chemical energy. So we have like different kinds of energies which are available, and the demand for this energy is also increasing. Now the question is, if the demand is increasing, we should be knowing from where we get this energy. The question is, where do we get the energy from? So when it comes to heat energy and light energy, we get this energy like mostly from sun, and sun is considered to be the biggest natural sources of energy to us. Sun is very important for us. Okay, so that is why they have stated that sun is the biggest natural source of energy to us, and many of our energy sources are also been derived from sun. Though the sun is not directly providing us with the other forms of energy, but still we are using that as a source, and we are coming up with different energy sources. So many of the energy sources we derive it from sun itself. Sun not only provides us with heat energy and light energy, it even provides us with other sources of energy as well. Okay, so we can also get energy from the nuclei of atom, from the interior of the earth, and from the tides. We know we have high tides and low tides, right? So even we get energy from these tides. Can you think of other sources of energy? Like they have already given us three different examples, that we get energy from nuclei of the atom, from the interior of the earth, from the tides, even like from dams. Whenever the water flows through the dams, we can even collect energy from that. Okay, so even we can collect energy from wind. So there are different sources from which we can have energy. Okay, so the word energy is very often used in our daily life, but in science we give it a definite and a precise meaning. It's not the one that we think of energy. It's different. Like we saw it for work. For us, if I'm sitting and teaching you something, I'm doing a work. But scientifically, unless and until there is no force applied on the object, and there's no displacement, I cannot conclude that work is done scientifically, right? Same way, because work is different and scientifically work is different, right? So scientifically you can say the definition for energy is also very different. Okay, So let us consider the following examples. First example given is when a fast moving cricket ball hits a stationary wicket. Stationary wicket means the wicket was stationary. It was not moving, it's stationary. Okay. So in that case, when the wicket is stationary, the wicket is thrown away, right? It was stationary, but there's a fast moving cricket ball which has hit it, and because of which the wicket will be thrown away. Similarly, an object when raised to a certain height gets the capability to do work. What I said? An object when raised to a certain height will get this capability that they can do the work. And you must have seen that when a hammer falls on a nail which is being placed on a piece of wood. Okay, what I'm telling, when a hammer falls on a nail and the nail is being placed on piece of wood, then it derives the nail into wood. What it derives into? It is derived into wood, and it derives the nail into the wood, because of which the nail is easily inserted in the wood, right? So we also have observed children winding a toy. Have you, like, anyone of you have like gone through it? You know that children doesn't keep toys with them, right? Like they keep on breaking their toys. So okay, so like you might have observed children's winding a toy, and when the toy is been placed on the floor, it starts moving. So when a balloon is filled with air and we press it, we notice a change in its shape. Right? You all might have done that. Like when you take a balloon which has been filled with air, and when you press it, you will see that there will be a change in its shape, right? So over here also we can say that there's some energy which is acting on it, and when the toy is been placed on the floor, it again starts moving, right? So this is how like energy is. Now, like till now I haven't introduced the exact meaning of energy, right? So I want you all to Please go through the slide once and then I'll give you the exact definition for it. After the C, as long as we press it gently, it can come back to its original shape and the force is withdrawn. Now let's say if you're applying the force, what will happen? You'll see that the shape of the balloon will change. But as soon as we are like going to release the force that we are applying on it, what will happen? The balloon will again come back to its original shape, right? However, if we press the balloon hard, it can even explode, producing a blastic sound. Right? We all have experienced this, how a balloon explodes, producing a blastic sound. So in all these examples, the objects acquire through different means the capability of doing work. So all the examples that we are discussing over here the objects acquire different means where the capability of the doing work will be different, and an object having a capability to do work is said to possess energy. So whatever object that we have and they have the capability to do work, we said that they have some energy. Okay, so the object which does the work loses energy and the object on which the work is done gains energy. Now this is the most important statement. Like whosoever the object is, if the object is like doing the work, the object is going to lose the energy, and the object on which the work will be done, that object will gain the energy. Okay, so how does an object with energy work? You can say that an object that possesses energy can exert a force on another object. What can happen? An object that possesses energy can exert a force on another object, and when this happens, energy will get transferred from the former to the latter. And we have like discussed this thing in the first part as well, that energy can neither be created nor be destroyed, but what we can do is we can convert the energy from one form to the other. So this is what is happening over here. So the second object may move as it receives energy and therefore do some work, and that is why the first object had a capacity to do work. Okay, and this implies that any object that possesses energy can do work. Like if I have energy in myself, then I can do work. If I don't have it, then it will become difficult for me to do that work, right? So if an object possesses an energy, that object can do the work, and the energy possessed by an object is thus measured in terms of its capacity of doing work. How do we measure it? In terms of the capacity of doing work. Okay. So the unit of energy is therefore the same as that of work, that is joule. So 1 joule is the, like if you have to define 1 joule, then you can define that 1 joule is the energy required to do 1 joule of work, and sometimes a larger unit of energy called kilojoule is also being used. So if we are using the term joule, we can even use like a larger unit for that called as kilojoule. So 1 kilojoule is equal to 1000 joule. Okay. I want you all to write important points from screen. I hope you all are writing all the like important sentences from here. You have to define one rule, you have to write the unit for that, and you need to write when the work has been done by the first object and the second object as well. Once you're done with this, like writing this part, all the important points from here, we will be discussing on the activity and then I'll stop for the day. So make sure you take the notes quickly so that we can proceed with the further part as well. I hope every one of you are writing all the important points and you have even taken points from here as well. So over here we have an activity 11.5. See, a few sources of energy have been listed above, and there are many other sources as well, right? So what you need to do is you need to list them all and discuss in small groups how certain sources of energy are due to the sun, because we know that sun is the most important natural sources of energy that we have, right? Then are there sources of energy which are not due to the sun? So we need to go through it as well. Okay. So you have to do this activity on your own. We'll discuss it once you are done with it. Okay. Then in the next class, I'm going to discuss with forms of energy, which are the different forms of energy. So some of the forms of energy have been given over here, like we have electrical energy, we have light energy, thermal energy, sound energy. So these are some forms of energy that we have, right? So after this forms of energy, we will be discussing on James Prescott, who exactly he was and how we got the unit as joule, because we know that Newton meter can be written as joule as well. So it was all because of James Prescott and the work that he has done. So we'll be discussing about him in detail. Then we'll discuss on kinetic energy in detail, and you will be even knowing how we can derive the formula for kinetic energy, that is half mv squared. Okay, so we'll discuss on that. Here we have the exact derivation part that has been explained. We'll be doing that as well. Then we have different examples of kinetic energy which have been given over here. We have activity 11.6 to discuss, then 11.7 to discuss in detail. Then we have example 11.3, 11.4. So like for just studying kinetic energy, we have different examples and activities which have been given. And this is to make sure that whatever we are studying about a concept, you're clear with it. Like you are actually clear with it and you're not rectifying the concepts, right? So make sure you know that. Then we have potential energy to discuss in detail. We'll be doing the we'll be discussing about potential energy. Then we will be discussing on activity 11.8 in detail. We have activity 11.9, 11.10, 11.11, 11.12. So continuous 5 different activities to ensure that potential energy is clear to you, because potential energy again is very important, right? So we already discussed on, like we'll be discussing on kinetic energy in detail with activities and examples. Same way we'll be discussing about potential energies with this 5 different activities, and after that we'll be discussing on potential energy of an object at a height. So if an object is at a height, what kind of energy does it perform and how exactly potential energy works there. Then we have example 11.5, 11.6 to discuss. After that we have the most important question that has been asked. Are various energy forms interconvertible? Can we convert the energy forms that we have or we cannot? So we'll be discussing on that. Then we have activity 11.14, and then we have law of conservation of energy to discuss. Now I tell you in I always tell you in all the parts that when it comes to conservation of energy, we should be knowing that total energy is always equal to kinetic energy plus potential energy. What it is equal to? Kinetic plus potential. So we'll be discussing kinetic energy in detail, potential energy in detail, and then total energy, that is conservation of energy. Because at the end, conservation of energy is the total energy, which is equal to kinetic energy plus potential energy. Then we have this activity 11.5 to discuss. We'll be discussing on that. We have this concept as rate of doing work. Is like the work everyone doing, is it done at the same rate, or everyone has a different rate of doing work? We will be discussing over here in detail. Then we have activity 11.16, then example 11.7, 11.8 to discuss in detail. See, we will be focusing on activities and examples because they are all very important for us, so we'll discuss on that. Then we have commercial unit of energy. We will be discussing on that, where we have like kilowatt hour, everything in detail. Okay. Then we have this example 11.9, activity 11.17. So there are so many activities in the lesson, right? We will be discussing on all. Okay. Then we have the summary discussion in detail, like what exactly we have done through the whole lesson, work and energy. In short, everything has been explained on the slide. We will be discussing on that, and then we have 21 exercise questions to discuss. So I am going to show you the exercise questions one by one, and I want each one of you to please go through them thoroughly, because you are the one who is going to answer them when we start with the exercise, right? So make sure you know it. I hope every one of you are going through the questions. So altogether, like, we have 21 questions to discuss, which I'm showing you one by one. So please go through it properly. So this is the last question that we will discuss at the end of the lesson, work and energy, and make sure you revise everything that has been discussed in this part. Thank you everyone.